next speakers are Steve, Jim from JFrog, and we have a remote speaker, Joel Marcey from Rust Foundation, talking about closing the supply chain security loop with Rust and Pyrsia. So we'll see if logistics will work.
Yeah, no, we tested this over lunch, and thanks very much for our lunchtime audience. It was helping us out, making sure that the setup worked, and getting the test working. So while we're getting Joel set up, I know I gave the earlier talk on Pyrsia just to introduce it, and Sudhindra also gave a few comments. But this is a great time to ask questions that I can answer for folks about the project or the goals or what we're trying to do. And what I'll go into in this presentation once we get Joel on is we'll talk a bit about the Rust language, why we chose the Rust language as the language of choice to implement Pyrsia, and also what we're doing to secure different language ecosystems. So I know I'm putting you guys on the spot now, but anybody have a burning question?
I'm here.
Here, you can have the mic.
So with Maven, it's and its complexities, same with Node.js. It's like, how far down do you go down the dependency chain to see if there's a vulnerability and licensing and?
Okay, yeah, that's a really good question. So I'm gonna answer that question while I flip the slides so you don't see my desktop. So one of the general strategies which we're doing on the project is we're going one language ecosystem at a time to make sure we can have a really tight integration with that language and create a good developer experience, right? So as a user, like as a developer or somebody like hooking up CI/CD systems to our toolchain, you wanted to integrate seamlessly, for example, with the Java ecosystem with Maven and Gradle. You wanted to integrate in the cloud native ecosystem really well with Docker and kubectl and all the Kubernetes tools. And what we're trying to do is make sure that for each ecosystem, we make it a very tight, seamless, easy integration. And we are going down the rabbit hole, the dependency rabbit hole, in terms of our own builds, our build from source, to build as much as we can, building everything from source. We're not currently going all the way up to like compilers and everything up the tool chain to completely build the whole world, but as we expand out like all the things which we're building, any dependencies we can pull from our own network, which are also built from source, we'll also be leveraging and using. So hopefully that answers.
And one more question is in the Jenkins pipelines and using a declarative or scripted commands, would you go into the JF step to execute those?
Okay, so I don't have an exact answer for this, and I have to get clarification, but for example, like whatever your build script is using that your Jenkins job calls, that's where we hook in. So like whatever the package manager is or wherever the build system is, instead of pulling from the central repository, we stand up a mirror. Yeah, and then you're pulling artifacts from Pyrsia into the cache via them, and then the mirror feeds that in like it looks like a central repository to your build. Okay, excellent questions. Now, you guys heard my introduction. I work for JFrog and I run the developer relations team. That's my handle, Steve on Java. So you can see all my random tweets there. And I am joined by Joel Marcey. Joel, would you care to introduce yourself?
Yeah, sure. Thank you, Steve. Hope everyone can hear me. Hi, everybody. I'm happy to be here at the CD Summit, even if only virtually. I'm Joel Marcey. I'm Director of Advocacy and Operations at the Rust Foundation, and I'm happy to be here with Steve presenting on this. Thank you.
Okay, cool. So glad to be able to co-present with you, Joel, even if it's virtually. I think this is the new normal, right? We can co-present even from across the world and or across the country. And I think when you look at Pyrsia as a project, as I mentioned, we've implemented Pyrsia entirely in Rust. So it's a new code base built from the ground up. And one of the questions when we started the project was why Rust, right? Why are we choosing a new programming language? Maybe, not all the tools or the libraries we need are there yet, so we actually have to contribute upstream to open source projects. We're helping to build out things which we need. But we're going to talk, Joel and I are going to talk about this a bit more, but when we looked at it as a project, Rust has a lot of big advantages. So first of all, it's a very high performance language, and when you're building something at the bottom of the tool chain that everything else has to sit on top of and has to support, the more performance you can give folks who are using your tools, then everything on top of that is faster, gives you better performance. The second big reason which we looked at Rust, and I think this is a lot of what we're going to focus on, is security. So we're a security-focused project. We want our project to be as free from accidental bugs, from intentional bugs, from to be easy to verify, to be easy to make sure that the code base is reasonably secure. And there are a lot of attributes of the Rust programming language which are really, really great for this. So let's talk a bit about the Rust programming language itself. So you want to give us the highlights, Joel?
Yeah, sure. Yeah, thanks again, Steve. So Steve started with a bit of a teaser showing how Pyrsia is written in Rust. That allows me to give a bit of a preamble about Rust before he dives into more details about Pyrsia itself, the open source supply chain, and potentially how you can get involved. Rust is in its 7th year as Stack Overflow's most loved language. Now, being a loved language is only part of the equation, right? You could be a really small language and really loved. But it's really important to know that it's really growing in the number of developers that actually want to use it. So you have this curve of loved language and developers wanting to use it. So Rust is actually becoming a formidable choice in the developer community. But here's how you know that Rust has made it into as a programming language. If Linus Torvalds is blessing the Linux kernel to have you as a supported option, that's probably a good thing. It's taking effort to get the support, but I think some facet of it should be there in Linux 6.1, which is scheduled to be available at the end of this year. And this is real benefit, right? Because it can expand the developer pool for those wanting to contribute to Linux. It allows Rust to be considered for new features or potential rewrites and those sorts of things. So it's actually a pretty big deal, and it shows that Rust is actually here to stay.
Yeah. So I was in the keynotes for Open Source Summit North America, where Linus talked a bit about their plans to further embrace Rust, make it a great choice for writing secure kernel extensions, but also looking at other ways they can integrate it. I think that that same sort of calculation, which the Linux project is making, a lot of companies are making as well. So one of the things which I think you know, at JFrog, we run Artifactory. It's the used package manager by the top companies, and we're increasingly seeing our customers for better and more tightly integrated Rust support, because they have teams in their company which are doing net new development on Rust. Actually, I was just in the Rust London meetup. I was in London last week.
There we go. Thank you, camera.
Thanks. So I was just in London, and I was hanging out with some folks over beer. So this is beer NDA. But I was chatting with a certain company which writes Salesforce software, and one of the guys there was working on a project to completely rewrite everything in Rust, and they're a big Java shop. So I think that there's a lot of initiatives companies are looking at where they can take advantage of Rust as a secure, modern, high performance language to meet the needs of their entire application stack.
Yeah. So Steve talked about this a little bit when he mentioned Pyrsia is written in Rust, but let me give you a 100,000-foot overview about what Rust actually is. This isn't a full-blown Rust talk, and there's much more that could be said, but at the high level, right, Rust consists of a programming language, libraries, and a worldwide ecosystem. And the language itself can create programs that are really fast, memory efficient, memory safe. There's no runtime, there's no garbage collector. Can power both performance critical services, run on embedded devices. On the ecosystem side, you can use Rust with things like WebAssembly. Rust has good documentation, a friendly compiler with useful error messages, and that's actually a really key selling point to Rust. For compiled languages, sometimes when you're programming and you're making mistakes, the compiler isn't always very helpful. In this case, the compiler actually almost fixes your problem for you. It's actually really good, so it's very productive. Makes you very productive. And there's top-notch tooling, including an integrated package manager and build tool, which is called Cargo. I want to focus on memory safety just for a moment here. Programs access memory, and depending on what programming language you use to write the code, there can be various ways to manage the allocation and use of that memory. Sometimes the programmer has to do it manually, sometimes the language compiler do it for you. However it is done, if it's managed wrong, really bad things can happen. So accessing memory that is not yours or part of the running program can cause massive security vulnerabilities, since that memory can contain sensitive information or be used to initiate an exploitation attack. It can even be a common cause of zero-day attacks. It's said that an estimated 70% of security vulnerabilities are due to memory safety issues. So Rust was designed to be a memory safe language by default through a concept what they call ownership. I won't get into the details of exactly what ownership is, but basically it provides a set of rules and guarantees for how memory is managed, such that your program won't even compile if those rules are violated. So if you have a program and it doesn't compile, it won't create an executable. And if you don't have an executable, it obviously can't run. And so you avoid memory problems in that respect. So this essentially eliminates the possibility of memory issues at runtime. There is a construct in Rust called unsafe, which is very much opt-in and very much explicit, that gives you kind of superpowers to dereference pointers and do all these sorts of things. I won't get into that too much, but just know that generally in the 99% use case of Rust, you won't be using unsafe and you won't be running into any issues. And in fact, even with unsafe, the compiler actually helps you out a bit. All this is to say that a Rust developer and those in the community that use Rust in their applications, they can have high confidence that memory vulnerabilities won't be an issue. So Rust is not just a first-class language, but it's an entire ecosystem of over 2 million developers, nearly 100,000 libraries, or what we call in Rust crates. This allows a huge litany of applications to be written via the built-ins that Rust provides by default and those third-party packages. And a really key thing to note is everything is open source as a core tenant of the Rust project. Everything's done on GitHub. There's a bunch of community channels on Zulip and Discord. And so everything's really done out in the open. So in that way, it's not hard to understand why Rust is actually becoming so loved and becoming so popular.
Yeah, so for Pyrsia, we actually use a bunch of Rust open source libraries. So we use P2Plib, so that's the underlying peer-to-peer infrastructure library that sits below IPFS. We don't directly use IPFS, but we use some of the peer-to-peer constructs to exchange files, build the network, and exchange artifacts over the Pyrsia network. And we also use a consensus algorithm based upon the left BFT libraries. So again, like we do our own immutable transaction ledger. We have our own design for how all that information is stored and how the blocks are constructed. But it's nice that we're able to take advantage of a bunch of libraries and different open source projects which are written entirely in Rust, which give the same sort of security guarantees to their users and to the downstream projects. And the ecosystem around Rust has been really, really strong for us to start a relatively new project like this, but then have all of the core infrastructure and features which we need to develop quickly.
Yeah. So all this to say is Rust is the panacea, and it's the solution to all of technology's problems. Well, no, that's not actually true. I'm not here to say that no other language should exist but Rust. That would be pretty disingenuous and absurd of me. There are many factors that go into choosing a programming language for a project, right? Existing knowledge, project domain space, budget, resources, all the things that we know about. But what I would like you to take away from here is that you should consider Rust as in any project that you embark upon. At least give it a first-class consideration. I work for the Rust Foundation, and it's the foundation's mission to support the Rust language, its maintainers, and its ecosystem. And what that means in practice is that, I think next slide. Yeah, what that means in practice is the foundation helps provide infrastructure to support the Rust project, maintains non-technical aspects of Rust like its trademarks and legal agreements, and creates and manages programs to support the entire community and help grow the use of the language. As we like to say, we got the boring stuff covered so that those that do the technical work can just focus on the things they love to do.
Yeah, and I think this is also another really important consideration for technologies in general is, I think we all do this. When you're looking for a new technology to adopt, you want to make sure it's well supported by like a vendor neutral consortium, so you don't get locked in on a single vendor. You want to make sure that it has a large community behind it so that you get the support and the patches and the upgrades which you need to be successful. And I think considerations like this, like is there a strong foundation behind it? Is there like multiple different industry leaders who are backing the language is really, really critical. And the Rust Foundation has a lot of big players who are supporting it. So Amazon is one of the key supporters of the Rust Foundation. We just joined the Rust Foundation as well. So JFrog is now a premier member, and I'm serving on the board of the Rust Foundation. And there's a whole bunch of other large companies which are investing a lot, Microsoft as well. So a whole bunch of companies which are investing a lot to make the Rust ecosystem successful. And I think they see the same sort of long-term value in investing in memory-safe languages and doing things in a way which they can improve the security of the ecosystem, and that's why they're doing this.
I think one more slide after that, Steve. I think I covered this one.
Oh, you already got this. So that next was to show the kitty, right?
To show the cat doing its thing.
Yeah. We don't want to. So I was obviously, as any good presenter, I was finishing my slides right before the talk. And because Cassandra, who's teaching one of the kids' workshops here, is looking over my shoulder. So what's your favorite slide in this talk? There's one. Yeah, the kitty. So you get points.
Nice.
by the next generation of programmers.
So the Rust Foundation has a vision for Rust, and basically it all boils down to Rust being considered a first-class, secure, and stable language that is trusted for use by everyone. And the only way this happens is by ensuring that the Rust project is well-resourced and supported with a diverse community. And by educating folks about the benefits and about Rust and its entire ecosystem. So while the Rust Foundation helps manage and shepherd various programs, initiatives, like we have a community grants program where we provide funding to those that apply and are accepted to do Rust things in the Rust ecosystem. We have cloud compute efforts, which provides access to like high-level infrastructure for folks to develop on the Rust project, so they're not doing all this on their laptop and things are taking hours to compile and test and all that sort of stuff. One big area that the foundation is focusing on is security. And basically, we're focusing on security as a means to encourage wider adoption and investment in Rust, but also because security is a really big deal nowadays, particularly with all the exploits and vulnerabilities we've seen in the industry. I think, next slide, next one after that, I think. Thanks. So vulnerabilities like SolarWinds produced a response from the US government through Executive Order 14028, which basically mandated solutions to solving security and software supply chain issues. We would like to see Rust be considered a legitimate candidate for this type of software work because of its focus on being such a secure and safe language. There's a list of programming languages on the National Institute of Standards and Technology's website. They call it the list of safer languages, like 7. I think there's a subset of some languages and full languages on others. We'd like to see Rust be a part of that list. And to that effect, the foundation announced a security program initiative with funding from OpenSSF's Alpha Omega and the great folks at JFrog to go explore potential security issues in the Rust ecosystem and work to resolve them. And what that means and what this initiative and funding will allow us to focus on are core security efforts within the Rust ecosystem, including secure software supply chain, language and crate security, and those type of issues that may arise. So we're going to hire into the foundation both security and software engineers to directly work with the Rust project and within the Rust ecosystem determine gaps and help implement best security practices. And in addition, we're going to hopefully engage with other external efforts like through the aforementioned open source security foundation and relevant government initiatives to advocate for Rust's role in developing safe and secure software. And this brings me back to Steve a bit. Pyrsia can play a role in helping secure the software supply chain, and I'm going to let Steve talk more about that now. So,
cool. Thanks, Joel.
On to you, Steve. Yeah.
One more comment on security, and I think this is another important consideration when you're looking at like investments in in particular programming languages and ecosystems. So I'm probably, you can tell from my Twitter handle, best known for being a longtime Java developer and running the Java community at Oracle. And one of the initiatives which we had there when I was part of that team was reducing technical debt on Java and the Java ecosystem, because you had basically decades of poor decisions on security, leaving things in like core libraries which were not heavily used and had security exploits. Basic like making sure there was good test automation, resolving all the outstanding security issues, and the team basically stopped feature development for a couple of years just to focus on paying down technical debt on security issues. And I think that for a relatively new language ecosystem like Rust to have the foundation understand and be making these investments early in getting additional security researchers to be looking for exploits, putting priority with the Rust security team on quickly addressing and fixing any security issues which are outstanding, and basically paying down this, ever-evolving technical debt on security issues. And this is another strong reason to consider language ecosystems like Rust, which are really focused on making sure that you have a secure ecosystem. So as a project, oh, that's my laptop. All right, let's make sure we're logged in. Hold on. You can tell by how much I'm typing that I care about security too. Okay, so the project we announced this morning, Pyrsia, is about securing the open source supply chain, and really we focused on a few key things. So we focus on having a fully open source solution, making sure that we can do good verification across different companies of the binaries, and having a vendor neutral governance for this. And Rust is a really good base language for this because it helps us with security guarantees. It makes attacking the code base harder for potential attackers who are looking at it. But I think also when you look at, we're talking about the Rust Foundation, when you look at foundations and ways of supporting projects going forward, the CDF is also a really strong partnership in making sure that Pyrsia remains a secure and open and viable project for everyone to rely upon downstream for it. And there are some good reasons for this. So, I mean, first of all, we know this, the CDF is vendor neutral. It's open to different companies. It's part of the Linux Foundation. So that gives you a really wide set of companies. And most of the member companies who are contributing to Pyrsia are also part of the CDF. Something else which I think is important to state is that the CDF is a project-focused foundation. And this means that it has really good infrastructure for supporting new projects, for making sure that they get the right technical oversight, they have the right contributions, and that the health and future prospects of projects joining the CDF are well maintained. I think this is very similar to the CNCF. If you see the CNCF as kind of the big umbrella approach where they accept all projects. But I think what's also unique about the CDF, it is a very strong focus on continuous delivery. So both project focused, and it's also relevant for the domain, which we care a lot about doing reproducible builds, verification of builds, integrating with CI/CD systems to provide them highly reliable systems for doing your downstream builds that are based on open source. And this aligns well with the CDF goals, which are continuous delivery, securing the DevOps pipeline, and making sure that we have a strong foundation for all of our work in this space. So I think it's a really, really great alignment with the CDF mission. And for our governance model, this also is tied in really well with how the CDF runs projects. And to give some more details on this, basically, even though Persia is a peer-to-peer network, we only operate the consensus algorithms and allow writing to the immutable ledger by authorized nodes. And those authorized nodes are run by companies which are supporting and sponsoring the project and running build infrastructure. So, I mean, there's the companies I mentioned earlier, currently JFrog, Docker, Oracle, Deploy Hub, etc. What? Yeah. So Jenkins is a CD Foundation project. You can run runners, which are going to do builds for Pyrsia in Jenkins, or Tecton, or your choice of runner. And what we do is we set it up so it's a vendor-neutral organization where all of these companies are running their builds. They're doing verification across the builds they get, and those are what get published to the Pyrsia peer-to-peer network. And I think this model works well because we now have a governance body which can do things like control what the PR process is for new additions to, for example, the package management ecosystem, or can also control which member companies are joining. So we have a large distribution. It doesn't get weighted too much towards like a particular sector or particular ecosystem. So it helps us to keep the overall governance of the project balanced. And this supports kind of this model of having a decentralized network and also having strong verification and review of the builds which are getting involved. And to get more involved in this project, there are a couple ways. So if you're part of the CD Foundation, or if you're part of a company which might be interested in contributing to this infrastructure, come chat with myself or Sudindra or Lori, who's your wonderful MC for the day. And we'd be happy to chat with you about what it means to get involved more with Pyrsia, how you can help out. And there's a bunch of different contributions we're looking for, ranging from like just help us run some infrastructure so that you can actually run one of the authorized nodes, all the way to like help contribute to the project, do commitments either to the Rust code base or to some of the CI/CD pipelines for doing the verified builds. And the second thing is, if you're an individual or if you're just an open source hacker who wants to get involved in the project, it's a fully open source project. It has contributors from both the member companies, and we have a bunch of folks who are not. We have contributors from IBM, who's currently not a member company, from some independent students, and from other folks who are just contributing to open source. And it's a great way to learn the Rust language, to kind of explore and be part of an up-and-coming open source project. And I think, hopefully a lot of fun. All of our meetings are open. You can attend all of our meetings, which are on Zoom. You can join all of the mailing lists or the Slack group, and it's all done in the public. So it's an entirely transparent process for getting involved with and joining the Pyrsia project. So I want to thank everyone for listening to myself, and especially for Joel, who's joining us remotely as a presenter. And I think we have a few minutes for questions. Okay. So yeah, Joel and I can take a few questions from the audience on any of the topics we talked about. It can be about the Rust community. It can be about Pyrsia. It can be about the t-shirts, whatever you want to ask. Nope. All right. Sounds like we answered all the questions. Thank you very much, Joel, and thank you guys for letting us present.
Have a good rest of your conference.